in the grand tapestry of time. Across the expanse of galaxies and planets, one cannot help but ponder. What civilizations have risen, gazed into the celestial abyss, contemplated the same cosmic mysteries, and asked the questions that echo. Are we truly alone in this vast universe, or does life transcend the boundary into the journey of exploration in life beyond? The dawn. As we embark on the quest for life beyond our planet, we find ourselves compelled to first look inward, appreciating the staggering complexity of life as we know it. The fundamental question arises, what does it take to create life? The staggering complexity that surrounds us is truly remarkable. How is it possible? What does it take to create life? Living organisms are created by chemistry. We are vast compositions of chemicals. Now, what sets the stage for chemistry to flourish? Primarily, it demands energy. Exploring the depths and intricacies of the text, we uncover a rich array of ideas centered around the importance of energy in chemistry. The narrative emphasizes the significance of striking the right balance, neither too much nor too little, akin to the ideal conditions found on planets situated just at the right distance from stars. Diversity becomes a key player in this cosmic tale, with a cascade of heavy elements contributing to the intricate dance of life. Oxygen, carbon, sulfur, and others form the celestial orchestra, creating the symphony of elements essential for the evolution of complex chains and molecules. The importance of liquid, specifically water, is highlighted as a crucial factor. In the dynamic environment of liquids, atoms have the freedom to cruise, cuddle, and form vital molecular connections. Liquid water emerges as a catalyst for evolution, providing the perfect medium for complex processes to unfold. As we delve into the narrative, we find a Goldilocks scenario where planets, particularly our early Earth, manifest the ideal conditions for these cosmic processes to thrive. The text paints a vivid picture of a celestial workshop where the delicate interplay of elements and energy sets the stage for the evolution of life.
Journeying back 4 billion years, Earth existed in a form vastly different from what we know today.
Positioned just right from its star, it cradled immense oceans of liquid water. Deep beneath the surface, at the Earth's crust fractures, a fascinating alchemy unfolded as atoms engaged in exotic combinations. While the exact recipe remains a mystery, the ingredients for life are surprisingly simple: energy, organic molecules, and liquid water. Somewhere within the early Earth's seas, basic chemistry metamorphosed into biology. A process that may have occurred multiple times. The birth of the first cells likely transpired in hot volcanic waters, a scenario once deemed inhospitable for biology. As we delve into the intricacies of life, we uncover its resilience in the most extreme environments. Microbes on our planet have adapted to thrive in hostile conditions: arid deserts, frozen Himalayas, and ocean trenches under immense pressure. Surprisingly, in the vacuum of a space simulator, life forms have flourished for years without oxygen. Recent research suggests that life emerged over 4 billion years ago. During a time when Earth was an alien and deadly place. Join me on this cosmic journey as we explore the unexpected origins and remarkable adaptability of life on our planet.
The planet was engulfed in the chaos of intense volcanism and a relentless asteroid storm that endured for an astonishing 100 million years. Yet against all odds, and in the face of extreme adversity, life managed to find a foothold. Remarkably swift, life's inception on Earth occurred almost immediately after the planet cooled following its tumultuous formation. This swift emergence on our home planet leads scientists to postulate that life's quick onset might be a universal phenomenon, echoing on other planets across the vast cosmic expanse. The Earth's narrative offers a beacon of hope, suggesting that life could be a universally common occurrence. Diving into the depths of our understanding, it becomes evident that we have merely skimmed the surface. Nature's treasury of secrets seems infinite, waiting to be unveiled. The galaxy we know is brimming with water, organic molecules, and complex chemistry. These essential ingredients, the very ones that sparked life on Earth, are scattered abundantly across the cosmos. So it begs the question, could the same incredible phenomenon that gave rise to life here have also unfolded on other planets?
The number of planets in the observable universe that could support life is truly astonishing, more than all the grains of sand on Earth's beaches combined. Yet, even in this vast abundance, most worlds remain hostile, unwelcoming to life as we know it.
The Milky Way could host 100 trillion moons, 100 times more than planets. Some may have Earth, like atmospheres and liquid water, making the discovery of life a matter of when, not if.